In your assignment are several problems where you're asked to do left and right Riemann sums for large numbers of subdivisions, for n equals 500, for example. Obviously, you're not going to be able to do those sitting there punching the numbers into your calculator, at least not in any reasonable time, not even in any time that any sane person would spend on this task. It's better if we can use derive. Now, derive has a built-in utility file, misc.mth, miscellaneous.math. Okay, this is the name of it. And we generally use this as a utility file. We transfer load it as a utility file. Now, this file contains a command, left underline Riemann, that will do left Riemann sums. I've modified that file so it will also do right Riemann sums. The file as it comes with derive only does left Riemann sums. I'll also note that derive, you don't need the misc.math. Derive, in its just standard implementation without any utility files, does integrals. And we'll see what the syntax is. First, if you're going to use the misc.math, you transfer load utility file. Okay, that's your command line commands. Transfer load, then choose utility, then misc.math. You could load it as a derive file instead of a utility file, then you get to see all the commands on your screen. But unless you know derive pretty well, it's just going to clutter up your screen and you're not really going to understand what you see. Now, the syntax for the left and right Riemann sums are left, the underline, Riemann. Now, let's say we're wanting to do the left Riemann sum of the sine of t squared. Okay, we would then put the function sine of t squared in there. Now, t is your variable, so we have to tell derive that that's the variable. And we have to do, when we do a Riemann sum, of course, we do it between one number and another, one t value and another, if the function is a function of t. So let's say we want to do the sum between t equals 2 and t equals 3. So we would put it in like this. We'd say t comma 2 comma 3. You have to tell it what the variable is, what the left endpoint of the interval is, and what the right endpoint of the interval is. Then we'll say 500. Okay, the 500 indicates that we want to do 500 subdivisions. We're going to divide the interval from 2 to 3 into 500 subdivisions. We're going to do a left Riemann sum of the sine of t squared between 2 and 3 with that 500 divisions. Now, that's of course going to give us a pretty good approximation to the area under the curve. On each small tiny interval, we're going to use the left hand value of sine of t squared to calculate the area of the interval. Then we're going to add all 500 up. That, you should know very well by now, is what the left Riemann sum does. If we want to know exactly what the integral is, well, we can do the integral command. That's a very simple command also. int for integral, left paren, you tell it what the function is. In this case, it would be sine of t squared. And then t goes from 2 to 3. Okay, so this will calculate the integral of the sine of t squared for t going from 2 to 3. Of course, close that with the right parentheses. And we can also do a right Riemann sum. It's just like the left Riemann sum, except we use the word right instead of left. And it will, of course, in each of the 500 tiny subintervals, take the right-hand value of sine of t squared on that interval and use it as a basis of calculating the interval. If the sine of t squared was a strictly increasing function between t equals 2 and 3, and it's not, it's increasing for most of that distance, but not all of it, then we would expect for sure that the left Riemann sum would be less than the integral would be less than the right Riemann sum.